In this problem, we're given a sine graph to start with, and based upon that sine graph, they want us to find the a value, the vertical stretching, and the b value, the horizontal stretching that we would have had to have done to the original sine graph to make it look like this one. So where I start on this problem is I start with the a value. So the a value in this situation, the formula for finding the a, max minus min divided by 2. That formula doesn't care if we're talking about sine or cosine. We just need to know that the formula for finding a is always max minus min divided by 2. So the next part of this would be to go ahead and find our max value, and we look at our graph, and the peak, anywhere we see a peak, is going to give us our max. So that's a good spot right there, and the y value that goes with that is 2. I go to find my min value, and any valley that I can find will work for that. So there's a valley right there, and the y value that goes with that valley is -2. So now that I know my max and my min, I go ahead and plug them into this formula. So I start with a parentheses, 2 minus, and then a -2, and then close on that, so a double parenthesis at the end, and then divide that by 2. From there, I'm going to go ahead and take and plug that into my calculator to figure out what that value is. So I open up my calculator, and I just enter it exactly how I have it. So again, I'm going to start with a parenthesis to start with, 2, and then minus, and then another parenthesis around the -2. Close the first one for the -2 and close it again for the whole top piece. And then I'm going to divide that by 2, and I hit enter, and I get out of there a value of 2. So this is the base of our a value right now. On questions 4 and question 5, we have to be very careful because those two situations, a could be negative depending upon the shape of our graph. And since what we're looking at right now is a version of Q5, we have to take that into consideration. How we know whether or not we're going to make it positive or negative is based upon how the original sine graph looked. And so that's what I have down below here. This is the original sine graph without anything having been done to it. When we look at the original sine graph, we're looking at where it hits the y-axis. And what we can see here is that where it hits the y-axis on the original graph should start by going up. And so if our graph starts by going up, then we know that the a value in that situation would remain positive like we calculated. However, if from that starting point our graph would have gone down to begin with, then if our graph goes down, we know that our a value would end up needing to be negative. There's no real way of knowing other than this type of data. If it's a sine graph and it starts by going up, our a value would be positive. If it's a sine graph and it starts by going down, our a value would be negative. So when we go back to look at the graph that we're actually have in front of us, we can see that our sine graph starts by going up. And since it starts by going up, we know that our a value needs to just remain positive. So +2 is going to be what we get out for the a value in this situation. So now that we found the a value, we get to go find the b value, how much it got stretched horizontally. We have a formula again for finding the b value, and the formula for the b value does not care if we're talking about sine or cosine. It's always the same formula. It's 2 pi divided by the period. The period is the distance it takes to do one full cycle of the graph. So sine and cosine graphs just repeat the same cycle over and over again, and so we call one full cycle a period. And so what we do to find our period is we can pick any point we want to on the graph, and we just find how long it took before we got back to that exact same point, before the cycle begins again. When I can, I like to use the starting point of the y-axis because it's easy to find the distance from there. So tracing my graph, I would have gone up, I would have come down. That first point right there is not going to be one full cycle. I haven't gone through the whole process yet. I need to keep going through a valley, and then what I see is that gray dot right there. That's where I end up completing my cycle and starting a new one. So that distance from there to there is what we would consider to be one period. Usually what happens, or not usually, but oftentimes what happens is that dot right here would have ended on a nice clean x value, and whatever that distance is from 0 to there would have been what our period is, our one full cycle. What we're looking at right now, you can see, is a point somewhere in between 3.14 and 4.71. And how far that is actually 2/3 of a unit going on right there. And so in this question, you can either have half units or 2/3 units. And how you would know this other than doing it a million times like I have, I don't know. But just know that when you're doing this problem, when we're dealing with the b value, if it looks visually like this one does, that it's slightly more than half, that it's just past the halfway point right there, then we know what we're looking at is a 2/3 unit situation. Again, if you hadn't done this a million times, there's no way you should generally just know this or assume this just by looking at the graph. But I can tell you that you're only ever going to worry about half units and 2/3 units. So what we need to know is what 1 unit would have been. So we look at this and we come back to our original graph here. And so looking at our original graph, what we can see is that 1 unit, 1 block, is this distance from here to here. So 1 block in our world, 1 unit was equal to 1.57. We need 2/3 of a unit to get ourselves from 3.14 right here over to where that line crosses right now. So we need a 2/3 unit. So we take 2 over 3 and we're going to multiply it by what 1 unit is, 1.57. So again, I'm going to use my calculator to calculate out what that is. So I pull the calculator up and I do 2 divided by 3 times 1.57. And I go ahead and hit enter. And that tells me that my 2/3 unit is 1.04666666. So this is my 2/3 of a unit right there. And that's what that little extra distance past 3.14 is. So I want to take my 3.14 and I'm going to add to it this 2/3 of a unit to get myself out to this point. So I'm going to add to that the 1.046667. So in this situation, my period is going to equal, and again, I'm just going to open up my calculator, and I can just grab the answer from the line above by hitting plus, and then type in the 3.14. And so from there, I get 4.18666666. So 4.186666. That's the total distance from the starting point at 0 over to where my graph crosses the x-axis right there. So don't forget that that's just the starting point for figuring out our b. What we then now need to do is go back to our equation and enter in what we just found out. So our b would equal 2 pi divided by the period that we just got, which would be the 4.186667. So in this situation, you'll take your calculator back out and you go ahead and you're just going to type in 2 pi and then divide it by, and the answer on the line above is what we want to divide it by, so you'll just hit second and then the answer button, which is in blue above the negative sign down below, and hit enter. And what you're going to find out of there is that your b value is equal to, and they want us to round it to 2 decimal places, so that would have just been 1.50. So our b in this situation took a bit more work, but the answer is 1.50. My little hidden secret, though, to you that is, if you ever get this 2/3 unit is what you're looking for, the b value in that situation is always the 1.5. So that's another way to just memorize this, is if you end up with a 2/3 unit, your b value, no matter where you're at, is always going to be 1.5. Otherwise, you have to go through this whole full process to find out what 2/3 of a unit is and add it on to whatever your base of the process is.